Okay, it's recording. Hello and welcome to the Wednesday, April 11th Cluster API working group under SIG Cluster Lifecycle. We have 2 items on the agenda, but as always, feel free to add items or just jump in after we work through the agenda. Like always, I have a pretty bad cough today, so I'm probably going to be on mute as much as possible, so I'm not coughing into the recording the whole time, but we'll get started. The first item, we have Cluster API Tooling and a link to a document. It looks like there's a public document out there. Does anybody want to talk on this?
Yep, that would be me. Okay, can anyone hear me?
Yeah.
Cool. So this is my stab at what the experience of using our tooling might look like. Basically an end-to-end. It's not supposed to be a user guide, but it's one step before a user guide. So what I wanted to do was show what inputs this tool will need and what outputs the user can expect, including error messages and stuff. And so what I can do is just quickly go over the document, because I think it would be boring if I recited the whole thing here. And so what I really wanted to do was reuse as many of the open source tooling and principles that already exist and then build on top of that. So a lot of the actions operations the user might want to do, including upgrades and updates, are done using kubectl instead of yet another tooling. What I also wanted to do was make the tooling consistent and standard. So whether you use GCP or you use AWS or you use Azure or Azure, it should be pretty much the same experience. And because nothing in life is easy, we are also going to be relying on documentation quite a bit, especially this quarter when we're trying to prioritize some features over others. And I'll talk about that in a little bit. So right now, if you're reading the doc as I'm talking, I'm on cluster definition section, which is the first or the third subheading, I think. Yep, thanks, Chris. And so, if you've used Cluster API or if you read the KEP, you need a cluster spec and a machine spec to create your cluster. It's pretty much the same as what was proposed, except in the machine YAML file. We have broken down versions, which is right now just the control plane version, into each of the components. And that's what I've highlighted there right now. Another small change is any non-master machines that are spec'd won't necessarily have the core component versions, because that doesn't make sense. I think the users can still specify it, but the controller will just ignore it. The provider config stays the same. I still have it as a string encoded JSON, although now we've moved to a raw extension, but the basic idea is still the same. The next thing, which is missing right now, is multi-cluster management. Right now, kubeadm creates a cluster and calls it Kubernetes. So if we try to create multiple clusters using Cluster API, we get our kube config file will be overwritten. To get around that, I'm proposing that we use cluster name, which is already present in the cluster object, and pipe that into kubeadm, which pipes it into the kube config. And so this way we can reference a Cluster API created cluster using the cluster name, rather than using weird kube config file copies and moving the files around and stuff like that. This currently does not exist in kubeadm. I have a PR out for that. Lucas had concerns about use cases and alternative options. I tried to address it the best I could, but if someone has other opinions, the PR is linked in this section, and I've highlighted that. So next is debugging and logging. Right now, I think we don't have much debuggability in the GCP deployer tool we have. And what I want to do is follow the kubectl model of verbosity specified through a command line argument. So this will print out the logs in the command line, but along with that, we also want persisted logs. And from prior experience, I think the helpful thing to do is just save everything the program is doing in on disk, and that's what I think our tools should be doing, is just save everything in the disk. And if someone wants debuggability, they can just look at the logs there. There's a question about unique cluster names. I don't think there's a way to enforce it right now, but that's a really good point. I don't have a good answer for that, except that the tool could check the existing kubeconfig file for a cluster name that the user wants to create, and if it exists, we just error out. Not sure if that's the best answer, but I'll take a note and create an issue for that. Okay. So now we're on to the actual tooling experience, which is the section called Oss Cluster Api Tooling. And so what I tried to do here was show the flow of what doing each operation might look like. And the first one I tried to address is cluster installation, the most important thing. It looks pretty similar to what we have right now in our GCP deployer, or the new Terraform deployer that I have PR out for. The one difference is that we allow the user to provide their own certificates. kubeadm init generates its own certificates, but we also want to allow the user to specify their own, and we just pipe it down to kubeadm, or copy the certificates onto the master and skip the generation of the certificates in kubeadm. The other thing that's different is this likely this might change a little bit based on how the bootstrapping process happens, which is discussed in the doc I've linked below. But if we're creating an external stack to create a master machine and then pivoting onto that, the logs should be pretty similar, the steps should be pretty similar. And irrespective of what provider / module we're using, this should pretty much be very, very similar. For cluster deletes, same thing, except now we let the user select a cluster by a cluster name. This does not exist right now. And this is something we can do after the kubeadm PR is merged and new kubeadm is released. The delete is, actually I'll talk about priorities in a bit. The machine update section is pretty much using just machine deployment and kubectl. You just kubectl edit and the controller then takes over. This currently works, except we don't use machine deployment, we just reconcile individual machines. For GCP, I've tried changing machine type, and it worked just fine for nodes, not for masters. For cluster upgrade, this is still being talked about by various people, and I don't have a good answer. I don't have a good story for the internals of how it will work, how the controller might work, how the tool might reconcile. But I think we should still just use kubectl to edit the cluster, the control plane components, and then some controller somewhere should reconcile that. This is a bit harder in a single master configuration, because where does the controller live now? So it is possible that cluster upgrade for single master configuration might need to be done maybe in the tooling, maybe using an external stack that Jessica was talking about, but I don't have a good answer here. And finally, and this has come up a couple of times, is cluster registry. The tool that we'll make will also just send a request to register the cluster with a user-managed registry. Probably the one thing to call out here is that the tool does not have any smarts like managing auth or error handling or managing private cluster. Because the scope is so wide and broad, we're letting all of that be fully managed by the user. So if someone's using Active Directory for their on-prem, it is assumed that their local setup has credentials to access the cluster. One last thing I want to talk about is how we're going about prioritizing this work. We are working on creates and upgrades before we work on delete this quarter, because we want to get the tooling and cluster API tested in multiple environments and get it in front of more people who test real world cases. And we find that create and upgrade will probably be used way more than deletes will be. But if someone is eager to help with deletes and they really like nuking clusters, we're obviously open to help. And I think that's my spiel.
So I have a quick question. This is a proposal for a new tool. Would this working group own this new tool? And how would existing tools like what's in kubedeploy, kops, and the other provisioners that are out in open source fit into this scope?
That's a good question. For the first part, yes, it will be owned by the SIG, and unless the repositories change, I plan for it to live in kubedeploy. So more or less, this will be the GCP deployer renamed with a few changes here and there. As for kops, I don't know much about kops to really answer that. I think it is similar to kops, except it is built on top of Cluster API. But I think if someone else on the team has a better answer for that.
Yeah, I mean, certainly no objection to this in terms of what kops is doing. I think the machines API. So there will be some similarity, and if we can share code, I think that would be great. For people that don't know, by the way, I have joined Google. So if I should probably make that clear before anyone gets wrong idea. But yes, certainly I can't imagine that it will be practical for kops to adopt to just switch to cluster, but like sharing code and sharing the ideas, I think is great. And I think, you know, we want a diversity of tooling.
Okay, I feel kind of the same way. Like there's packages that I've used and written both in open source in Kubernetes and in Kubicorn that might be handy here. But my opinion is us coming together and building a tool that's owned as a community is probably the right move for us. Mm-hmm. So if that's what this proposal is, I'm really interested in it.
Yeah, I would say that at this point we're not necessarily this is like, you know, to be the single tool. I think the diversity of tooling, you know, it is great what we have today. I think if over time, then it makes sense, we start, you know, converging, you know, even better. If not, you know, at least have like a, you know, we expect this tool to be like not necessarily with all the bells and whistles that are like other tools have, right? But then I have like a basic, you know, tool as part of this SIG and as part of the Cluster API sort of important, so you don't need necessarily to go in and learn and adopt some other tool to make this work, right? Specifically the bootstrapping, which is a big functionality there.
And one more thing I should add is I don't mean for this tool to be very heavy and contain a lot of business logic. I think that should live in the controller. So if people want to build their own tools, they still can. I would rather the generic pieces be pushed upstream to this tool itself. But I see this more of as a lightweight orchestrator of cluster API clusters.
And the other thing, please go ahead.
Just a quick clarification. I noticed the API you have spec, or the use case you have spec'd out here, have a provider flag. Is there a plan to support like a generic provider specification for people who say don't have a nice alias? Because this looks like this alias has to be compiled into the CLI, and that's not very friendly to people who want to prototype other controllers and bring their own.
Right. That's a good. I thought about it a little bit yesterday, and the only thing I could come up with is if you want to prototype your own provider, fork the repo and add another flag.
So as far as providers go, I had a pretty long discussion yesterday with Fabio and Patrick about this, and we started toying with an idea of using a gRPC interface and having the provider run as a sidecar container in a pod that's deployed next to the controller, so that we don't get into situations like this where we're having to hard code provider-specific information into our binary. You just bring a different container. I think it's a good pattern.
Okay. That's kind of like what we've done with the machine controller already. Is we give you a generic library and you provide an actuator and you build your own binary. It's not like a sidecar container that communicates over gRPC. You just link your own container with your business logic substituted in there. And what I was thinking about this, depending on how this is invoked, maybe GCP is just an alias that's compiled in for a container that contains a controller for GCP and a way to run it. And maybe we provide another way for them to just specify, like, here's a container and a way to run it to start the business logic up for that provider. But I don't like if you want to add something to this, you have to fork, prototype it, and then submit it back to the main repo. But we can talk about that as we go forward. I mean, at a high level, I don't see any major problems with this.
Okay, yeah, that's a good point though. It is definitely not the best way, because we're still if all I care about is GCP and this tooling, the binary, it has all of the other providers baked in, that's also not ideal. And Chris, the CL you sent, kind of got around that by reversing the dependency, so the controller doesn't depend on all of them. And I think it's the same problem that you've brought up with this provider thing.
Yeah, in my mind, ideally, this has no provider-specific code linked in. It only has a container that it can run that listens to the cluster API. You feed it cluster, you talk to it. Like, the cluster API is its gRPC interface that Chris was talking about. But yeah, we can go down that rabbit hole in another discussion.
Okay.
Go ahead, sorry.
Yeah, one thing I was going to bring up is Karan mentioned the cluster upgrade, and I think we should probably within like a couple of weeks, have a discussion about that, because we've had some discussions internally about that, and we have Kenny on the team working on a document as well. Going to share with the community some thoughts around upgrade. So that's coming up, and I just want to mention that.
Any other comments?
Is the name of the new command line tool open for discussion?
Definitely.
Just checking.
This is I think the other proposed suggestion was deployer, and this tool is more than just deployer, so I just came up with yes, it's open to suggestions. It's not a great name, yes.
Okay.
Do you have any suggestions right now, Chris?
I have one Kubernetes themed name I've been waiting to use for a good project. I can associate it with mountain pictures, but we can list something more verbose. I think would be a good fit here.
Yeah, I'll explicitly add here, open to.
Yeah, it might make sense to send an email. Well, I think you share the document, but just send an email, to the Google group, asking for suggestions. Try to close on this, on any feedback and suggestions by next week, by next meeting. Sure.
Okay, and then I have to put on my working group organizer hat here. Where would this code potentially live, and do we need to communicate with the broader SIG to get a new repo up and running?
I think kubedeploy is fine. More or less, this will be an independent tool that pulls in all of the cloud, at least one of the cloud providers. And so wherever the cloud provider lives, that's where I think this tool should live. I don't think this is worth creating a new repo, though.
I think the question is, does it deserve to be in the repo we've already created, the Cluster API repo? And we haven't moved to it yet.
Right, yeah. I think the intention of the new repo was to just host the API itself, right? I think this should more or less be treated like a satellite tool that just consumes that API, and so I think kubedeploy is probably fine.
I guess we could have a more descriptive repo name, right, for this. Since we create another one for the API, maybe another, we can keep in kubedeploy for now, but create a separate one just for this tool, maybe whatever we call it, because the discoverability of this tool in kubedeploy might not be that great.
Right.
Yeah, I would want to suggest we keep the new cluster API repo whenever we move to it for the API only, and then this tool being a standalone repo owned by SIG Cluster Lifecycle, worked on by Cluster API Working Group.
Okay. So would the cloud provider code then also move to that repo, or what's the plan of record currently for that?
I think that is a great question. I don't have a good or strong opinions on an answer to that right now.
Okay.
I think the cloud provider specific stuff should not move to that repo. And I think having this tool in a separate repo from the cloud provider specific code is a great way to enforce that it's not cloud provider specific if we can help it. I mean, that's, in my opinion, a long-term goal. If we can't get there initially, but we want to get something out, I'm fine with it being somewhat tied to cloud providers, but long-term, I don't want it to be.
Okay.
Okay. Action items for this. I think probably cluing in the rest of the SIG and giving us a week to go through this doc, ask questions, kind of let it simmer, and then next week we can take action on creating a new repo, finalizing the proposal, stuff like that.
Sounds good.
Cool. Does anybody have anything else here? This is an exciting proposal.
Does anyone want to talk about the kube control plugin? There are some comments on that. I just kind of want to give some room. So want to talk about that, Martin and Jason has some thoughts.
I mean, I think if this new tool can be just a kubectl plugin, it will be better because you don't have to install it in your path. It's not another tool you have to learn, and then you don't have to have all this boilerplate code that you need to add just to create it. So if it works as a plugin to kubectl, it will be even better.
I haven't looked at all the kubectl plugin stuff. I just learned that this was available as alpha in 1.10. But I think there's still a lot of stuff to set up. It looks like you have to install a separate binary for this path. You put it in. You have to configure the kubectl plugins path, and you have to also install a plugin descriptor. So while I think it's something to consider, I think it might just be swapping out one boilerplate for another and one installation headache for another. I agree. It might be a better interface if we can think about it. But,
right. I didn't know this existed, but I will read about that and maybe add a note about
yeah,
that.
I should just mention this is my like 5 minutes of looking at this documentation. I'm not that knowledgeable about it, but it looks like it would have some installation issues and some other configuration issues that we have to solve one way or the other.
Right.
But that's neat. Cool.
Yeah. Looks cool.
Sorry about that. Anything else on the proposal? Going once. Going twice. Cool. Next agenda item, adding owner references to machines created from machine set controller. Looks like there's a pull request.
Hi, can anyone hear me? Yeah. All right. Hey, Jessica. Can you hear me?
We can, but you are very distorted and overdriven.
Let's see if I could correct that.
Maybe there's someone else who's knowledgeable about this that can speak to it.
Speak about what, Chris? Oh, the pull request?
Is this better?
It is not. You're still pretty distorted.
Chris, you want to talk about it?
Yeah, maybe I'll talk about it. You mute yourself. Okay. So I've been reviewing this. Basically, it's adding owner refs to the machines that the controller creates, and it's basically so the garbage collector can do cascading deletion. So when you delete the machines, that it deletes all the machines it created. There's a lot of complexities that come up with this because when you have owner references, you have to worry about adoption and orphaning them, and that's some of the stuff that's still open on the review. But we just wanted to point out that we want to add this for the cascading deletion behavior. And I know Martin's already taken a look at this, or he's at least left a review comment, but we'd like to get some more eyes on this to make sure that everyone's okay with it. Did I miss anything, Kenny? You can type in chat if I did.
Okay, looks like Kenny said that is good. And I can try to take a look at it, and I'm sure some other folks will as well. Anything else on that pull request? Cool. Next up, Karen again with the Terraform provider pull request.
Good job on the name pronunciation, by the way.
Thank you.
I was prototyping a provider and a deployer tool for vSphere, and Terraform seemed like a good choice for that because we don't need to implement API client again. And so what this PR is a prototype, nothing more than a prototype of creating a cluster in a vSphere, in a VMware lab environment that meets certain restrictions, like your image has to be Ubuntu 16.04 with the capability of getting an IP address, aka networking has to work. with certain SSH keys that the keys are hard-coded. The path to the keys is hard-coded in this prototype for now, but I have follow-up issues and to-dos to migrate them to a path unless there's a better solution, which Chris is looking into. I've also added documentation for anyone who wants to work on this machine, on this controller image or the tool. And my hope is this is simply a prototype. We check this in so others can contribute the improvements that this needs. And currently, the way it works is the provider config takes a Terraform config, which is HashiCorp config language encoded as a string in the provider config, along with the variables that you define in your VM template. And it saves them on disk, runs Terraform, copies the Terraform config onto the master, and then pivots onto the master where the controller can then reconcile the node. I've tested it, it works, creates a master, creates a node. I'm able to deploy Nginx pods to it, and our lab doesn't have an external load balancer, so I can test external traffic, but at least traffic within, networking within the cluster seems to be working. I should say only create works. Delete, upgrade, not much there, nothing there actually.
Yeah, and we would welcome actually if there's anyone on the call or in the SIG, with more experience to actually help us shape that code. That'd be great. We have experience with both Terraform and also vSphere, because this is a little bit has been tested more against vSphere.
How are we using Terraform? Are we actually vendoring the Terraform command line tool?
Yes, I am checking in the binary version, that a specific version, but the alternative is we just wget the tool onto the master instead of copying it over.
I think we can build a container image with Terraform in it and use it that way.
But that's the master, right? Or sorry, not the master. The machine controller is vendored with the Terraform binary. Actually, correction. In the initial version of this prototype, I was copying over the binary, but now I just bake it into my machine controller, and it's already added to the path. And so, yes, it's vendored in.
Okay. Okay, anything else on this one? I don't have any major problems with it. I think the previous discussion earlier about the new command line tool, we're going to start to walk down a path that in the future might be relevant to this PR, but for today, this is a good starting point.
Yeah, I think this was just more of an FYI of what's going in so people are aware. It's something we want to prototype and work on to see if we can get a generic Terraform controller working for people who know Terraform and want to get that get started up with the cluster API. And we just are prototyping with vSphere because we have the lab.
Okay. I also wrote a Terraform SDK, so you can vendor the Terraform code base. Not production ready, but it was a pretty good proof of concept for anyone who is interested. It basically gave you the functionality to create a slice of string that mimicked the Terraform command line flags you would use, and it would accept a slice of bytes that would be the Terraform config. And then you could do apply or any other Terraform commands with it.
Oh, cool.
Could you provide a link to that in the meeting notes?
Yeah, exactly.
Yeah. Question, did you have to save those bytes on disk? Because Terraform doesn't seem to take standard input.
you passed it bytes on disk. It used a
Okay.
temporary file, and it would just manage all that for you. It felt like you were passing in a stream of bytes, and
Right.
it would read from a temp file.
Got it. That's pretty much what this is doing, except in a very hacky way.
Mine was also extremely hacky, and the big problem was as Terraform evolved, because I did have to hack the Terraform code base, there would always be this manual, like, we have to go and update our code as Terraform grows process.
Right.
So it would be like, oh, there's new release. Now there's this chore of going and updating our SDK.
Right.
Um,
Good to know, though.
I'm putting a link in now. Anything else on the Terraform stuff or in general?
I was wondering if we've ever discussed having the actuators run as a separate component and use the API to run I guess asynchronously and not to be called from the controller code directly. Is that in the future plans?
Yeah, I think that's roughly what Chris was talking about earlier with...
It depends on what you mean by that. Oh, which Chris? Sorry.
You, Chris Rousey.
Okay.
Yeah.
It depends on what you mean by that. Currently, the machine controller exists as a library in which you pass an actuator implementation into it when you construct it, and you basically link your own binary and run that. So the main library that does a lot of the niceties for you, all you have to do is worry about implementing a machine interface, but that is called in process. And you're saying you're interested in making that external?
Right. So sort of, I guess, do we have, do we have maybe a timeline, or do we have plans for moving the actuator out of code in the same way, I guess, that cloud providers moved out of code? So maybe there's still an actuator, some sort of library that fronts the implementation, but that runs separately from the controller.
But so all the controller would do would be interact with the actuator. So why does it need to run separate? We already have separate controllers for the machine set and upcoming type machine deployment. That's already in a separate binary along with the cluster controller whenever we get that. But
okay.
Right now the machine controller is its own separate binary, and you have to compile your own with your provider specific logic compiled in. So it is kind of already separated out.
Okay, yeah, that answers my question usually.
Okay. And from what I understand, the core cloud provider stuff is going the same, kind of the similar implementation of where they're just going to pass in a cloud provider interface implementation. It's not necessarily a controller with control loops talking over like gRPC to an external process. It's just you have control loops with cloud provider specific implementation, and then you have the generic controller manager that's going to handle all the generic API stuff.
Right. Thanks.
Okay.
If we have time, I have two things I want to bring up. Are we cool right now?
Yeah.
Okay, I'll continue. So the first is I've been going through the API generation code, and I'm starting to have a bit of concern around the actuator. For those that may not know, we're using API Server Builder to generate the code, and we are actually modifying the generated code. And I guess I'm wondering first is if we have plans to influence API Server Builder to address that case. And if we have thought about the implications of whether API Server Builder, I guess the support burden of that's going to come with us modifying the generated the generated code on a regular basis as we update the API?
So
A really good question.
yeah, there was I'm the one who did that. I submitted the PR that modified the generated code, and the generated code that was modified was some of the code that constructed the machine controller. And this was so we could get that separation of the actuator out, as you pointed out. Someone on their review mentioned that they were interested in maybe upstreaming this support to the API server builder. And I said I would be more than happy to review that and help them do that. I was not going to do it myself. I'm of the opinion that that piece of the code we regenerate so infrequently that it's not that huge of a burden. And also, like, the major churn for code regeneration is going to be, say you add a field or you update an API type. You're going to need to regenerate the deep copy, the conversion, and I think that's, and maybe the validation too. And I think that's it. You don't need to regenerate either the client or the controller unless you add a new top-level type, which will generate a new controller for you anyway. It's not going to modify the existing one. So, yes, there is some manual work if you ever do rerun that regeneration. Like, say we upgrade to a new release of API Server Builder, there's manual work to go back and modify that code again. But there's also manual work involved in updating to the new API machinery library, because that's also not stable between minor Kubernetes releases, as we have found out, which is why Mason had a hard time going from the 1.8 version of API Server Builder to the 1.9, was the API machinery libraries weren't a stable API. So yes, if someone wants to upstream that support, I will more than happily support that, and I will review it, and I'll make sure it meets the needs that we have. But again, we only do this for the controller, and I only foresee it. We only have done it for the machine type, and we will probably do it for the cluster type in the future, but those will be the only two types. All the others should be able to have generic implementations and not need the actuator abstraction.
Okay, that's fair. The reason why I ran into this is I recently added a makefile at the top level of Cluster API that's actually broken right now, so I'm trying to fix that. And I do have a fix for it, which will generate the code in a Docker image, but already running into differences just by running the tool. And there's the only semantic differences are the actuator pieces, but there are things like, replaced imports and stuff like that did crop up.
Okay. Yeah, I think I reviewed that first PR, and I'm willing to follow up with you on the second one. But I think the main cases we want to capture are the API regeneration stuff for the deep copy and conversion and validation. I would like a make rule to regenerate the controllers, but maybe we should note around that process about some of the idiosyncrasies we have right now, and then work to fix them upstream.
Yeah, that's kind of where I was thinking too, just kind of live with it for now until we have a better plan.
Yeah, I am more than happy with that, and we can document that at least in the makefile and in the code we modified, and hopefully just say, dragons be here, beware.
Yeah, I actually found the comment that says, we actually have a comment in I think it's in the Google actuator that says, like, if this does not compile, it's probably because you ran the API generation code. So there's that. The other thing I want to bring up is, have we talked about this at all? Is a single controller or a single API, cluster API implementation that could manage multiple actuators at once? So, like, for instance, I guess maybe it's not in the cluster type because we don't have cluster actuators yet, but I don't think it's in the machine type either, where we define which actuator you intend to use for a machine.
We've been relying on the provider config part of the machine type. It'll have like a type and name. And for instance, if we like if the Google actuator gets a machine and it doesn't have a GCE provider config in there, actually I don't know, but it should ignore it and just say, this is not meant for me.
Well,
I could.
Will that work? Because that's because that's just a generic type, right? If I'm just wondering if we should pop out another top level field that's just provider name.
No, it's not a generic type. The provider config is a serialized field. It's a runtime.raw extension, and we say it should be an API type of itself, an API type itself that is provider specific. And there's even support for it to actually reference another API type. So like if you can define a CRD to make it a full-blown API type. And you could just have an object reference to the machine provider config. And it would definitely say the type is GCE provider config. And so an AWS actuator would be like, this is not an AWS provider config. I'm going to ignore this machine.
Okay, I'll take a look at that again.
So what is the use case, Craig?
So I think there's definitely use case that we would want to have perhaps a single controller that's out of tree, or I should say a controller manager that's out of tree that may use. I think as we get to clusters that are right now it's one-to-one or one cluster for many machines, right? I think we may encounter the scenario when we advance the code where we have multiple controllers. Sorry, I'm using the word controller. Multiple clusters, one machine to multiple clusters. I think when we get to multiple clusters, you might want to define them on different actual downstream actuators. So one could be on Google, AWS, etc.
Yeah, in that case, you could just run two controllers and one should ignore the other API types. But if you wanted to write your own actuator implementation that peeked into the provider config and forwarded it to the appropriate actuator, you could write a single binary that does that.
Do we have any thoughts on perhaps maybe we should just use some label selector on the controller so the controller knows what machines it's responsible for or something like that?
Well, I think that would be a good idea. I'm also unclear on how we intend to implement just how a machine belongs to a specific cluster. Because right now it's all just one cluster.
I was talking about this last night as I started to brainstorm writing a controller to demo for TGAIK on Friday. My first kind of gut response to solving that problem was to do a string compare and check for the name of the cluster. And if the name of the cluster is relevant in a tag, the machine name, whatever, however you want to store that in your specific cloud provider, if that does match with that string, then we take ownership of it. But whether that's a label or a cluster name, like, I don't know if that's the best way.
Yeah, my first impression was also just a string match.
There was talk about adding another field just to point to as an object reference to the owning cluster in the machine. Like, I explicitly belong to this cluster object.
Yeah, that's what I was thinking, actually.
But after reviewing Kenny's controller reference, I did not know you could have multiple owners in the owner's references, so it also might make sense to just put the cluster as a non-controller owner reference in the machine if we can just reuse the metadata that's already there. That's something I'll have to look into. I should have an action item to go look into that and report back if that is something that we can use.
I've been using this, and I can suggest, yeah, this is the correct path, at least in my experience.
All right, good. I'm glad to have external verification on that, and it's not just a harebrained idea.
Great questions. Anything else on any of Craig's questions or in general? Going once? Twice? See you guys next week.